Welcome to all. Myself, R. Vivek, Assistant Professor in Mechatronics Engineering, K.S.Rangasamy College of Technology at Tirunelveli. In this video, I am going to talk about the subject is mission design. So already I posted unit number 1 in previous video. If you are not watching that video, kindly go and watch that video. So today I am going to talk about unit number 2. It's nothing but the shaft and coupling. In unit number 2, these are the topic I am going to cover the topics. The first topic is design of solid shaft based on the strength. Second one is design of solid shaft based on the rigidity. And third one is design of solid shaft based on the critical speed. And fourth is design of keys. And next one is design of rigid and flexible coupling. And last one is design of knuckle joint. Let's see one by one. So first I'm going to talk about the knuckle joint. Knuckle joint is used to connect two rods whose axes either coincide or intersect and lie in one plane, used to transmit axial tensile force, unsuitable to connect to rotating shaft which transmit torque. Joint permits limited angular movement between rods above the axis of the pin. Typical application of metal joints are joints between the tie bars in the root trusses, a joint between the link of two link of suspension bridge, a joint in the valve mechanism of reciprocating engine, fulcrum for the levers, joint between the links of bicycle chain. The diagram shows the knuckle joint shaft diagram. Knuckle joint is used to connect two rods whose axes either is coincide or intersect or and lie in the one plane. Advantages of knuckle joint is the joint is simple to design and manufacture. There are few parts in the knuckle joint which reduces cost, improves the reliability. The assembly or dismantling of parts of knuckle joint is quick and simple. Design of knuckle joint is so these are all the parameters involved while designing the knuckle joint. So first one P is nothing but a tensile load acting on the rod, and D is diameter of the rod, and the small D1 is diameter of the pin, small D2 is outer diameter of the eye, small t is thickness of the single eye, and G1 is small t1 is thickness of the fork, and eta t is permissible stresses for the joint between tau is permissible stresses for the joint, and tau c is permissible stresses for the joint of crushing. So next topic is keys. We all know that key a piece of a mild steel inserted between the shaft and hub of the pulley to connect this together in order to prevent relative motion between them. Key is machine element which is used to connect the transmission shaft to rotating machine element, a temporary fastening subject to considerable crushing and shearing stresses. A keyway a slot is in the shaft or hub of the pulley to accommodate the key. A next function of the key is primary function of the key is to transmit the torque from the shaft to the hub and vice versa. Second function of the key is to prevent a relative rotational motion between the shaft and the joint motion element. These are all the major functions and functions of keys. First one is primary function of keys to transmit the torque from shaft to hub. This is the primary function of the key. And second one is prevent the relative rotational motion between shaft and the joint motion element. These are the two functions of the element. The main drawback of the key is a keyway result in stress concentration in the shaft and the part becomes weaker. Here are some diagrams for sunk keys. Types, see the types of key. The first type is sunk keys. The first one is a rectangular, square, and parallel, and feather, and with brief. Look at this diagram. And second type of keys, the saddle keys, and tangent keys, and round keys, and the spine keys. So these are all some diagrams for keys diagram. Keys are forces acting on the keys is what are the forces acting in the keys are compressing force and shear force. Compressing force is happened due to the tightening and torque transmission due to torque transmission. A shear force is happened due to the torque transmission. So the diagram clearly shows compression. The first diagram is the compression force. Second one is the shear force. So design of keys. These are all the parameters we must know while designing the keys. T is torque of the torque, and F is tangential force acting on the circumference, and is diameter, small is length of the keys, W is width of the keys, T is thickness of the key. These are the factors we must know while designing the keys. And last topic is coupling. So coupling is nothing but can be defined as a mechanical device that permanently joins two rotating shafts to each other. So coupling is defined as a mechanical device that permanently join a two rotating shaft is called as a coupling. So shaft connected by the coupling may have a collinear axis or intersecting axis or parallel axis, which a small distance in between. So by this axis method only, the coupling action will going to happen. So collinear axis, intersecting axis, and parallel axis. These are the three examples for coupling. So our engine to input engine, hydraulic pump, and electric motor, and compressor gearbox. Requirement of good couplings is there are four requirements for good coupling actions. So capable of transmitting torque and should keep two shafts in proper alignment, easy to assemble and deassemble, should be covered by giving a suitable shape to the flange. So these are the types of coupling. The first one is a rigid coupling, and second one is a flexible couplings. In rigid couplings, uh, so many types are available. The first type is split and clamp and flange coupling. Flange coupling is one of the most used in manufacturing industries. In flange coupling, we have subtypes of protected types, unprotected type, and marine type. And flexible coupling, there are three couplings are there. First one is pushed thing, and second one is universal coupling, and third is hold-on coupling. So flange coupling. So consists of two flange, one feeder to the driving shaft and the other to the driven shaft. So we all know while transmitting a power, and there is a driving gear and driving shaft. Here the coupling is a driving shaft and the driven shaft. And second, connected together by means of 4 and 6 bolts arranged on a circle concentrate with the axis of the shaft. One of the flange has a protected portion and the other flange has been corresponding to pieces. The flange coupling is adapted the heavy loads and hence it used to a large shafting. These are the parameters we must know while designing the flange coupling. T stands for diameter, and D1 is a nominal, and D is the outer diameter. Capital D1 is the diameter of the board.
D is outer diameter of the flange, and N is number of bone, T is thickness of the flange, and tau T, tau S is equal to corresponding shear stress. Look at this diagram, corresponding. So for easy understanding, look at this diagram. Shaft. Shaft is rotating machine element which is used to transfer power from one place to another place. Shaft is used for transmitting power. So bending movement, fairly, we all we all well know that. And shaft is axial and is spindle. Axial is a stationary machine element, and spindle is a short shaft that imports motion for cutting tools. Properties of shaft are it should have high strength, machinability, power sensitivity, good heat treatment, wear resistance. These are the problems we must have with the shaft. Types of shaft is transmission shaft and then machine shaft. So design of shaft is strength and rigidity of the stiffness and the critical speed of the shaft. So time, due to the time, so I'm going to end up this session. So thanks for watching. Keep learning and growing with K.S.Rangasamy Technology.